Welcome to this explainer. Today, we're going on a bit of a trip, a micro-macro journey, if you will, looking at how matter transforms right in front of our eyes. I mean, we all know ice melts and water evaporates, right? But the actual microscopic mechanics, the way particles arrange themselves and use kinetic energy, it's like this constant, completely invisible dance happening all around us. By the end of this, I promise you'll be looking at your everyday environment through a totally different lens, the lens of thermodynamics.
Okay, let's dive right into this by looking at a very common everyday mystery. Have you ever wondered where those water droplets on the outside of your cold drink actually come from? Think about it. You pull a freezing cold bottle of water out of the fridge, you set it on the counter, and literally within minutes, it's sweating. The glass is totally sealed, so obviously the liquid isn't leaking from the inside, right? We see this happen all the time, but the microscopic mechanics behind it are actually kind of mind-blowing. To understand exactly what's going on, we have to zoom way in and look at the tiny particles that make up, well, everything. Now, check out this stark contrast between the two extremes of matter here. You've got rigid solids on one side and fast escaping vapor on the other. In a solid, those particles are locked down tight. They're rigid, packed in shoulder to shoulder, and they basically just vibrate in fixed positions. But on the complete opposite end of the spectrum, we have vapor or gas. Here, the particles are just going wild, moving incredibly fast, spreading far apart, always trying to escape. And sitting right smack in the middle of these two extremes is the liquid state. Liquids give particles just enough freedom to loosen up and sort of slide past one another. So what's the secret sauce to moving between these three states? It actually comes down to one single, incredibly powerful ingredient.
And that ingredient is heat. Adding heat, speeding up. To understand how matter moves between these states, we literally just need to turn up the temperature and inject some energy right into the mix.
So as we add heat, we create this one-way directional flow of energy. It happens in steps. First, step 1, melting. A solid absorbs enough heat to transition into a liquid. Then, step 2, vaporization. If we keep that heat blasting, the liquid absorbs even more energy until it transforms entirely into a vapor. Let's break down exactly what these tiny particles are doing at each of these two critical kinetic milestones.
Okay, let's look at melting. The absolutely crucial thing to remember here is that adding heat translates directly into kinetic energy, which is really just a fancy way of saying movement. When you heat a solid, the molecules start vibrating with so much intensity that their rigid little grid just collapses. The bonds loosen up, and the particles start sliding past one another. So a solid successfully melts into a liquid simply because its structural integrity gets completely overwhelmed by all that chaotic kinetic movement.
Now, what if we inject even more heat? Well, that's when vaporization happens. The liquid particles start moving incredibly fast, bouncing off each other and gaining so much kinetic energy that they literally break through the surface of the liquid and escape into the air as a gas. It's important to realize the matter hasn't disappeared like magic, it's just gained way too much energy to stay grounded anymore. So that's heating things up. But what about removing heat and slowing down? If adding heat acts like stomping on the gas pedal, removing heat is like slamming on the brakes. Let's see what happens when we throw this entire process into reverse. As we take a step backward, removing heat forces our high-energy vapor back into a liquid, that's condensation, and eventually locks it back down into a solid through freezing. It's the exact same path we just talked about, just walked in the opposite direction. That wild escaping gas loses its energy, huddles together to form a liquid, and then, as even more heat gets stripped away, the liquid loses its ability to flow and just locks up solid. And hey, look at that. This completely solves our earlier mystery from the start of the explainer. Condensation happens when invisible water vapor in the air hits your cold glass, loses energy, and slows down to form visible liquid droplets. Think about it. The air all around us right now is filled with invisible, fast-moving water vapor. When those highly energetic vapor particles crash into the freezing cold surface of your drink, the glass rapidly sucks the heat energy right out of them. The vapor particles instantly lose their momentum. They stop moving so fast, clump together, and boom, right before your eyes, they turn back into liquid water. Your glass isn't leaking, it's literally stealing energy from the air around it. How cool is that?
And if we keep stealing that energy, we get to freezing.
The crucial point here is that freezing is simply the ultimate loss of kinetic energy. When a liquid is exposed to a remarkably cold environment, that environment rapidly pulls the remaining heat energy right out of the substance. Those sliding, flowing particles move slower and slower until they come so close together that they can't even slide past one another anymore. They become completely fixed in place, forming a rigid solid. So looking at the complete picture here, you can really see what a beautifully symmetric system this is. And it's governed entirely by energy. Moving up the chain from solid to vapor requires adding heat, and moving back down requires removing it. Ultimately, every single change of state we observe in the macro world just boils down to accelerating or decelerating microscopic particles. Which brings us to science in daily life. Because this microscopic dance of gaining and losing heat, it isn't just some abstract laboratory theory. You are interacting with these energy exchanges literally every single day. Whether you're freezing ice candy at home, watching ice melt around fresh fish at the market, or drying palay under the sun, you are actively witnessing energy changing the fundamental state of matter. When you make ice candy, your freezer is acting as an energy thief, removing heat to lock those particles into a solid state. When farmers lay out wet palay or rice grains, the sun is doing the exact opposite, adding heat, giving the liquid water particles enough kinetic energy to vaporize and dry the harvest. Even the morning dew on the grass, that's just the cool overnight air removing heat from water vapor, causing it to condense into liquid drops. From the steaming smoke at a food stall to the melting ice keeping market fish fresh, it is all just one continuous flow of heat energy. So, I want to leave you with this final thought to ponder as you look at the world around you today. How will you apply this microscopic understanding of matter to your own daily life? Now that you know exactly how temperature manipulates particle behavior, you can actually use this to your advantage. Whether it's figuring out more efficient ways to dry your clothes, managing condensation in your home, or safely working with boiling water and steam, you now possess the scientific blueprint. The next time you see ice melt or a pot boil, I bet you won't just see water changing shape. You'll envision billions of microscopic particles dancing to the rhythm of energy. Thanks so much for joining me on this explainer, and definitely keep observing all the amazing science happening right in front of you.